So now let's talk about B, brightness of our framework. We're going to continue leading into our framework, and we stopped off at what is our light intent? What are we lighting? Whether it's a kitchen or a closet. When we look at B in the framework, brightness, we're not just considering the brightness, but we're also taking into consideration the CCT, which is the correlated color temperature, which we spoke about, or is it going to be an RGB light? We're also taking into consideration if we need a high CRI. Brightness is really an attribute of visual perception, in which case a source appears to be radiating or reflecting light. In other words, brightness is the perception elicited by the luminance of a visual target. So dealing with brightness, we need to take into consideration that there are factors that are going to decrease the light source output. So for instance, if we use an LED strip or a flexi strip within a profile, we spoke about the different diffusers that could remove the brightness levels. And we said that frosted covers could remove anywhere between 20 to 30% of the brightness. We spoke about black covers that are totally aesthetic, and they could remove up to 70% of brightness. Another factor that contributes to LED light loss over time, or LED lighting output over time, is lighting decay. So the LED naturally, like any other light source, loses its original brightness after some usage. And there are standards that call LM70 that we spoke about in the previous units that really identify what will be the functional brightness of the LEDs after X amount of hours. Then the third component we have to take into consideration is heat. If your LEDs are going to be exposed to a lot of heat, it's not just going to hasten the light decay, but it's also going to create sometimes what we call a chromacity shift or a shift in color. For instance, you may have a warm white LED, and even though you're using a good quality phosphor from a good manufacturer, a good supplier, if you have a lot of sunlight hitting that LED for whatever reason, it could cause that phosphor to shift color over time. So sometimes people may see in an outdoor installation that their LEDs have shifted from, let's say, landscaping lights. It started off as a warm white light, and the phosphor of the LED that makes it warm has decayed. You're going to see the LED turning to whiter. It's going to be like 4,000 or 5,000. Can you imagine when you use bulbs in your home and somebody mixed up the colors and you see spots of white or shades of white or warm white and white lights mix? That's what could possibly happen if we don't take these into consideration. So just to recap, the external factors that could affect brightness: diffusers could impact the LED brightness, or any sort of media you're using to backlight are going to affect the LED brightness. You have aging of the LEDs, and you have heat impacting the LEDs after long-term use. Before I continue in the next areas of brightness, I'm just going to recap some of the stuff we spoke about in lighting. So we spoke about efficacies and different lumens per watt. We're not going to be basing our installation off wattages. We're going to base our installation off lumens. What is the lumens I need to light a particular area? And in order to understand that, you need to understand a little bit about lux levels. And what is lux levels? Lux is the measurement of lumens per square unit area. It is essentially equal to 1 lumen per square meter. In photometry, this is used as the measurement of the light that can be perceived by the human eye. So imagine that the light is hitting off a surface and I'm seeing it in my eye. That is what my eye is detecting. And in some cases you have perceived lumens and actual lumens. So actual lumens could be recorded on a device, and perceived lumens could be very personal, because some people see things brighter than others, and that's relative. But we need to be objective, so you need to know what the lighting standards are for some areas. And I would mention that in a brief PDF so you could get access to it as a quick reference guide. Let's talk about some factors that will contribute now to the brightness of the LED applied in the application. Dark decor. So if you have black finishes or dark color finishes, they're going to absorb a lot of light. So if you're going to specify, let's say we're doing a kitchen countertop, a very easy example. You have under cabinetry lighting. We tend to use an LED that's at least 800 to 1,000 lumens per meter. And if the cabinet height is at 24 inches, it's going to be sufficient light. We're going to get the required lux level that we need. However, if that countertop, let's say, is black, it's going to absorb a lot of the light. And if we needed more light for that workspace or that work pane, we're going to have to increase the brightness. The same goes for dark cabinetry in, for example, closets, or you're doing ceiling lighting and the floor is black. Another thing that contributes, when we did a gym recently, they used matte surfaces. So the floor wasn't shiny or polished. So the type of surface could really absorb light if it's matte, or it could reflect light if it's gloss or semi-gloss. Glossy is going to reflect a lot of light, and you could also create a lot of sharp glares on the floor, but all these affect how much brightness is going to be reflected into the space. So on that gym, it looked very dark, but it was also part of the design intent to not look like a typically bright, overpowering gym, but they wanted it to be a little more refined gym. So that was part of the design intent. Let's put black matte floors and let's add a lighting detail so the place looks very chill and relaxed, and that contributed. So that was intentional. But if you're specifying something new or doing a retrofit project, these are the considerations that you want to take into mind if you're speccing to get the right light level. Another thing that could affect brightness in your installation is voltage drop. I'm going to cover that in engineering. So if you have a lot of voltage drop on your wire, your LED is not going to shine or work at its optimal output. And the obvious one is color temperature, whether you're going with a shade of white from as low as 1800 Kelvin to 6000, even 10,000 Kelvin we've installed already, or RGB, red, blue, green if it's an entertainment center and you need to add a splash of color. Even though you're dealing with splashes of color, you may want to note that not all RGBs have the same brightness. Different chipsets have higher brightness, and you may need to consider higher brightness chips in those RGB applications where the decor is very dark. The other aspect of brightness I like to consider, even though it's under brightness, is CRI. CRI, as you mentioned, is the color rendering index. If you were doing a clothing shop and you needed very rich colors, or any sort of retail environment, you would want a very high CRI. You would want up to 97 to make those products look stunning and all the colors to look accurate and the reds to look rich. You would want a very high color rendering LED. But note, the higher you go on the CRI, the lower the light output becomes. So you lose the lumens and ultimately you lose the lux level. So these are some things you have to take into consideration. So when you reach B and you're in that scenario, say, okay, I would typically use a 1000 lumens per meter and the CRI is 80, for example. You now have to consider, I might need a brighter LED, like a 14 watt LED that's going to give me, let's just say 1400 lumens. But if I raise the CRI, or if I buy a product that has a higher CRI, it's probably going to drop back down to 1000 lumens per meter. You have to read all your product details and specifications to ensure that you're selecting the right LED for brightness. So just to recap on B, things that affect brightness in the installation and things to consider are: 1, the finish of the surface that's going to be illuminated, the lighting standards that are going to be required for that task, your correlated color temperature, and finally your CRI. That brings us to the end of B, brightness. And let's move on to control and circuitry.